This is section 5.5, problem number 3. Before we get to the problem, though, let's look at what is an exponential equation. An exponential equation is an equation that has a variable in an exponent. So, for example, 3 to the x power equals 20, or 2 to the 5x power equals 64 are examples of exponential equations. The base to exponent property says that if you've got two numbers and they have the same base, then in order for them to be equal, then their two exponents have to be equal. And that's going to be very important to us as we look at solving some equations. So for 3a, we've got 3 to the x minus 1 power. Now we're going to rewrite 81 as a base 3. And 3 times 3 is 9, times 3 again is 27, times 3 again is 81, so that's 3 to the 4th power. Now that we have these two bases equal, then according to that property that I just gave you, that means the exponents must be equal. So our equation is x minus 1 equals 4. Add 1 to both sides and we get x equals 5, and that's the answer. All right, let's look at the second one. 2 to the 3x minus 7 power is equal to 2 to what power? Well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now, that means that I have 1, 2, 3, 4, 5 2's that I multiplied, so that's 2 to the 5th power. Now that my bases are the same, I can set the exponents equal to each other. So the equation I need to solve is 3x minus 7 equals 5. I add 7 to both sides, I get 3x equals 12. I divide both sides by 3 and I get x equals 4, and that's the solution.